Alright, this evening we're going to complete section 4.2, which is relations and functions. As well as 4.3. In 4.2, our definition of a relation is that it's a set of ordered pairs. You might want to take notes on your vocab sheet about that. So basically, one group of numbers is matched to another group of numbers. If you have a set of data, say track scores, and then the place that they scored and the points that they got, and this is actually out of your book on page 236. The ordered pairs are first place is 5 points, second place is 3 points, third place is 2 points, and fourth place is 1 point. This right here, when you have two circles, is called a map. This is the domain, which is your x values, and this is the range, which is your y values. You might have also heard of independent and dependent. This is the independent variable. That's the one that we're in charge of, and this is the dependent variable. So all you would do to map this is list your x values, this right here, your domain, 1, 2, 3, and 4. And then in the other column, you would list your y values, 5, 3, 2, and 1. And then you would draw your map. So 1 gives you 5, 2 gives you 3, 3 gives you 2, and 4 gives you 1. So this is a 1-to-1 mapping. For every x, there's exactly one y. Here's another set of coordinate pairs. So we're going to look at our set of data right here. That bracket means there's a set of ordered pairs, a solution set. And in our domain, let's go ahead and put these in numerical order. -1, 0, and 3. Those are each of our x values in our ordered pair. And then in the y value, let's also go ahead and put that in numerical order, 3 and 4. And you do not need to write the 4 twice. And then let's go ahead and draw our mapping. 3 goes to 3. -1 goes to 4. And 0 also goes to 4. So that 4 repeats. If you think about what this would look like on a graph, 3 is 3. -1 is 4, and 0 is also 4. So this is a function. For every x value, there is a y value. The y does repeat, but that's still a function. The easiest way for me to remember if something is a function is something called a vertical line test. And basically, when you draw vertical lines on your graph, if it ever hits your graph more than once, it is not a function. It's also not a function if the x repeats. If the x is written twice, that's what's going to make something line up. So if I also had the point -1, -1, I'll just add that in here. See how I'm failing this vertical line test because it's now hitting my graph more than once. Okay, I'm going to erase that because that's not what we're talking about. I just couldn't stop. All right, if you take the exact same 3 numbers that we just used, 3 would give us 3, negative 1 would give us 4, and 0 would give us 4. So we've got our table, we've got our map, we had our list, our solution set of numbers. So these are all just different ways to write relations, to write ordered pairs, to write sets of numbers, and a graph also. Holy moly. If you look at this graph, this is a different set of numbers. They're just the ordered pairs, but do you think this is a function? That's a 1-to-1 relationship. Remember that vertical line test is probably the easiest thing to do, and the vertical line test fails right there. So nope, because it fails the vertical line test. If you look at this data in the form of a table, if we start writing our numbers, this is -6, 1, 2, 3. And then this is 2, -1. And this number up here is 2, 6. And this number right here is 8, 6. So another reason that this fails, not because the y repeats, but the x. Right here, that's another reason that it's not a function. It's not a 1-to-1 relationship. You need for every x, there's a y. And this time, our x value has 2 different y's. And we can best see that if we draw a map, because in our domain, in our x, we have -6, 2, and 8. In our y, we have 3, -1, and 6. And then when you're drawing your map, -6 goes to 3. And, you know, it's nice if this is in order numerically, but it's also kind of nice to have it match up. So either way, it doesn't matter. This does have to be in numerical order. All right, and then you can see that 2 goes to -1 as well as 6, and then 8 goes to 6 also. So they both repeat, but the y can repeat, and the x cannot if you want to know if it's a function, which I just did. So, and I did that. So this relationship is random. There's not like a pattern. This looks pretty linear, and it's an increasing pattern. I mean, we could draw a best fit line fitting this data, and it looks like something called positive correlation. This we can say has no correlation. These numbers don't relate to each other. And then there's negative correlation, which is not on here, but negative correlation would be a decreasing slope, something that's going towards the negatives down. All right, so I already kind of talked about functions. I'm going to click through. So we can look at the map and make sure the x does not have 2 arrows, because that would mean the x repeats. If we have an equation, we could generate a table and make sure that the x does not repeat. And if we have a graph, we can check with the vertical line test. So if you look right here, I can just drag this vertical line, and it's never going to hit the red more than once. That's kind of what you're thinking. You're thinking about dragging a vertical line up and down across and seeing if it hits that graph more than once. So this is a function because it passes the vertical line test. Alright, so let's think about these. Does this first one pass the vertical line test? Is this vertical line ever going to hit the red more than once going across? It is a function because it doesn't ever hit it more than once. What about this next one? Bam, it fails all through here. So this fails the vertical line test. So not a function. And since you don't have a vertical line, just kind of think about drawing a bunch of vertical lines. And this, it never hits it more than once, so this is a function. And this one, we can see that it fails right there pretty quickly. If something's not a function, usually it's because you have some sort of like y squared or y cubed. If you can write an equation in y equals form, you most likely do have a function. So we are used to writing equations in y equals form. There's another form that's called function notation. So if you look at this is y equals x for this walkathon that I totally, well, I thought there was an, here we go. All right, so what this means is Leanne, this is an L of x, that's how you read this right here. So Leanne's function, we can plug any number in for x. And if you look at this, it's saying plug 4 in for x. So I know that y equals x. That's the same thing as L of x equals x. This L of x and this y really mean the same thing. But in function notation, when you're given L of 4, what that means is plug 4 in for x and solve. So L of 4, when I plug 4 into the function, I get 4. That's my answer. Y equals 4. It's the ordered pair 4 that gives me 4. Let's kind of think through this for the next one. It's a little bit harder. Gilberto's plan is y equals 2x. That can be written in function form as g of x equals 2x. And if we plug 4 in for g of x, remember our standard equation form is y equals 2x. Function form, g of x equals 2x. I want to know g of 4. So g of 4 is going to equal 2 times 4. I've plugged 4 in for x. So g of 4, when I plugged 4 into the function g, I got 8. That's telling me that when I plugged 4 in, I got 8. My ordered pair is 4, 8. And if you look at Elena's plan, 1/2 x plus 0.5 equals y. Elena, a of x, equals 1/2 x plus 0.5. So again, same thing. Y equals 1/2 x plus 5. I think I said 0.5 a minute ago. Okay, so a of x equals 1/2 x plus 5. I am plugging 4 in for x in Elena's equation. That's an A. If you're confused. So Elena, 4 into Elena's equation would be 1/2 times 4 plus 5. So that is 1/2 times 4 is 2. 2 plus 5 is 7. So Elena, if she does 4 miles, will get $7 if that's the whole walkathon story. Now, the confusing piece is sometimes, we're going to do this again, but sometimes when you have a of 4 equals 7, this means this. There's no solving for a. We don't need to solve for a. We know that the function of a is equal to that. If you start dividing by 4, that's just a big disastrous mess. So it doesn't even make sense. This means when you plug 4 in for x, you get 7. So dividing by 4 would do absolutely nothing. This is your x value, this is your y value, this is your ordered pair. It's function notation. So this next column, we're going to plug 10 in for each. So L of 10 would just equal 10, because if you remember, L of x equaled x. That was Leanne's plan. And Gilberto was g of x equals 2x. So we're going to see what g of 10 is. So we're going to plug 10 in for x. So Gilberto is going to give us 20. So again, this ordered pair, when you plug 10 in, you get 20. If you go back to Leanne, when you plug 10 in, you get 10. It's getting kind of... Alright, and then Elena, when you plug 10 in for Elena, remember a of x is 1/2 x plus 5. So a of 10, these should all say 10. I don't just notice that. Alrighty, so a of 10 would be 1/2 times 10 plus 5. Well, 1/2 times 10 is 5. And 5 plus 5 is 10. So Elena, when you plug 10 into her equation, you get 10. That's the ordered pair 10, 10, ironically. Same as Leanne. All right, for the last problem, we're just going to look at an equation. And it's in function notation because it says f of x instead of y equals. Again, this is the exact same identical thing as y equals x squared minus 4x plus 9. So don't be confused. All right, we're going to plug -3 in for each x. So I'm plugging the whole quantity of -3 into x squared. I'm plugging the whole quantity of -3 into that x, and then we have a plus 9. Now, -3 times -3 is positive 9. In the graphing calculator, you'll have to include the parentheses to get the right answer. If in the graphing calculator or many calculators you put -3 squared, you will get -9. And that's right, because that means -3 times 3. The 3 is squared, not the negative. We have the quantity of -3 squared. The entire -3 is squared. So to put that in the calculator, that's different. You would have to use the parentheses, and then you'll get 9. So use your brain. Make sure you put the right thing in. So 9, and then we have minus, and make it plus a negative. And a negative times a negative is a positive, so that's a positive 12 plus another 9. So we've got 18 plus 12, which is 30. So f of -3 gives us 30. This means the ordered pair -3, 30 is in our map, in our table, in our graph. So there's no like dividing by 3 equaling 10. That doesn't make any sense. This is our x value. This is our y value. This is function notation. This time we're going to plug 5c in, a letter. So this is going to be even more exciting. So 5c squared, that means they're both squared, minus 4 times 5c plus 9. All right, 5c squared means we're going to square both the 5 and the c. So you get 25c squared. Minus 4 times 5c is 20c, and then plus 9. You can only add c squareds to c squareds, so nothing is like terms. So this is our final answer. And then the last one, I need to actually just see the problem. We're plugging 5 on the outside of f of c. So we're plugging c in for x, and then we have a 5 on the outside. So I'm going to color code this. So this 5 is on the outside of the whole equation. And then the equation, c is going in for x. So we have c squared minus 4c plus 9. So our answer would be to distribute this 5 to get rid of the parentheses. So we have 5c squared minus 20c plus 9 times 5, which is 45. So you really have to read your initial function notation. This is what you plug in for f, for x, into the function f. Hopefully that made a ton of sense. I'll see you tomorrow.